Hi you guys, I'm ready for lesson 3 of module 15. This is actually the second to last lesson. I didn't realize how short this module was, so pretty exciting. Yesterday we did the lesson on comparing fractions with the same denominator, and today we are doing the lesson on comparing fractions with the same numerator. So numerator is the number on top, the parts being counted. So I'm super excited about this. I hope that you're starting to notice some patterns with working with fractions, and that's really what we want for you guys as third graders, to just be familiar with fractions, what they mean, what they represent, that they take up space, and to notice patterns. So here we go. The I can statement says I can compare fractions that count the same number of equal parts when the whole is divided into a different number of equal parts. Okay, so basically what that means is denominators, the bottom number, different. Numerators, the number of equal parts being counted, is the same. So let's start this spark your learning. It says Nita and Bennett are riding in the Around the Park bike ride. Nita completes 3/4 of the ride. Bennett completes 3/6 of the ride. Who rides farther? Show one way to compare the distances. So now, as with comparing any fractions, we have to make sure that the wholes are the same. So the whole ride is the same for both Nita and Bennett. We are just dividing that ride into different sections, right? Just like we learned, if you have a ruler, it's the same ruler, but you could divide it into halves, half inches, or you could divide it into fourths. Still the same ruler, we're just dividing it differently. So Nita completes 3/4 of the ride. So that fraction 3/4 is very important. That tells us that her ride we're dividing into 4 equal sections. So I'm going to do that now and be as accurate as I can. Okay, 4 equal sections, and she completed 3 of them. 3 of the 4. So I'm going to color in 3/4. That's how far she got. Now Bennett completes 3/6 of the ride. Same ride, we're just dividing it into 6 equal parts instead of 4. So I'm going to do that now, again, the best I can. That's pretty good. So this Bennett's ride is divided into 6 equal parts, and we're going to count again 3 of them. Like that. So since my fraction strips are the same length, meaning that the wholes are the same, I can trust my visual model and see that Nita has done more of the ride. So who rides farther? Nita. Nita rides farther. We can see that just by looking at the visual model. So the turn and talk says, what is the same about both fractions? How does this help you find out which fraction is greater? So the thing that is the same is the numerator. So the thing that we are counting is the same. What's different is the denominator, how many equal parts are in the ride. So it kind of helps us. It's kind of tricky because they're the same. So with yesterday's lesson, when the denominator was different, we could just look at the numerator and be like, oh, that's a bigger numerator, that's a bigger fraction. But with this one, we can't really do that same thing. We have to be a little more thoughtful about it. Okay, so the next page says build understanding. It says Ellen and Tanya both plan to film 1-minute videos. So far, Ellen has filmed 2/6 of his video. Tanya has filmed 2/3 of her video. Who has filmed less so far? So they're both 1-minute videos. Their whole is the same, so our fraction strips are equal to each other. Ellen's, or I think that's his name, Ellen is going to be divided into 6 equal parts because he has filmed 2/6 of the video. So I'm going to divide this into 6 equal parts as best I can. Okay, and then I'm going to fill in 2 of them. Now Tanya has filmed 2/3 of her video, so I'm going to split this up into thirds. Okay, so thirds, and then 2 of them have been completed. So as we can see, since the whole is the same, 1 minute, the fraction strips are the same length. They're just divided into a different number of equal parts, but I can trust my visual model and see that 2/3 is greater than 2/6. So it'll say write less than, greater than, or equal to. 2/6 is less than 2/3. Who films less of the video? Ellen. And how do you know? Well, because 2/6 takes up less space than 2/3 does. All right, number 2. Rocky hikes 5/6 of the Pinot Trail. Rinny hikes 5/8 of the trail. Who hikes a greater distance on the trail? Again, same hole, same trail, just divided into a different number of equal parts. So Rocky, his trail is divided into 6, and he travels 5/6. So this first number line is divided into 6. I'm going to count 1, 2, 3, 4, 5, 6 right here. And that is the length that Rocky hiked. And then Rinny hikes 5/8 of the trail. So this number line is divided into 8 equal parts, but as you can see, the number lines are equal to each other because it's the same trail. So I'm going to count 5/8. 1, 2, 3, 4, 5 right here. And that shows how far Rinny hiked. So how can you show the distances on the number lines? Which fraction is closer to 1? Which fraction is closer to 1 whole? Well, 1 whole is right here. What's the closest one? This top one, Rocky. And Rocky's fraction was 5/6. So it says write less than, greater than, or equal to compare the fractions. 5/6 is greater than 5/8. So who hikes farther? Rocky. Okay? The Turn and Talk says, how does the number of equal lengths in the whole affect the size of each equal length? How can you use this relationship to compare the fractions in task 2? This is actually a major thing that we should discuss. So the number of equal lengths in the whole does affect the size of those lengths. And I think we've talked about it before, right? If we have, I'll grab a whiteboard. If we have a pan of brownies, that was the example that I used last. Well, I keep picking wrong markers. If I have a pan of brownies that I made, and I want to share them with 5 other friends, I would have to cut up 6 equal parts of the brownie. Okay, if I were to take this exact same pan of brownies and only divide it into 2 parts for me and one other person, the size of the pieces would be much bigger. So 2 equal parts and 6 equal parts. The more pieces I have to fit in the whole, the smaller the pieces are going to become. So when we look at 2 fractions, I'll bring this back. This represents how much of the brownie I would have if I shared it with my 5 friends. This represents my slice of the brownie that I would have if I only shared it with one other friend. So what is a greater amount? 1/6 or 1/2? Clearly, 1/2 is the greater amount. So as the denominator goes up, the size of the parts decreases, it goes down. So if I were to just look at these numbers, I would say 1/6, 1/2, which is greater? Automatically I know 1/2 is greater, because I'm imagining 6 equal parts within the same pan of brownies. So just like with yesterday, when the denominators were the same and the numerator changed, we could look at it really quick and be like, oh, that numerator is greater, so that is a greater fraction. Now, if the numerators are the same and the denominators are different, we can look at those and automatically think, okay, that denominator is smaller, which means those parts are bigger, which shows a greater fraction. Mind blown. So cool, right? Okay, so let's continue. Number 3 on page 411, it says, Aiden climbs 2/9 of the way up the rope ladder. Reed climbs 2/5 of the way up the same rope ladder. Same rope ladder, that's important. Who climbs higher? How do the numerators compare? The numerators are my top number. 2/9, 2/5. Numerators are the same. How do the denominators compare? Aiden, the whole is divided into 9 equal parts. Reed, the denominator is, the whole is divided into 5 equal parts. So whose equal parts are larger in size, and how do you know? Reed's equal parts are larger in size because we are dividing only into 5 parts, right? There's less partitions. Are 2 of the equal parts in Reed's climb smaller than or larger than 2 of the equal parts in Aiden's climb? Well, since Aiden had to fit 9 equal parts in the same rope climb, those parts are going to be smaller than when Aiden divided it into 5 parts. So Reed's, are 2 of the equal parts in Reed's climb smaller than or larger than? They are going to be larger than Aiden's. So if we compare the fractions 2/9 to 2/5, 2/9 is less than 2/5. Who climbs higher? Reed. Okay, we didn't even have to draw a model for that. We could just be problem solvers. So cool. Okay, check understanding. Roxanne paints 4/6 of a poster red. Max paints 4/8 of a same size poster red. Who paints more of their poster red, and how do you know? Numerators are the same, 4 parts and 4 parts, out of 6 parts and 8 parts. So if the denominator, the bigger the denominator, the more equal parts have to fit in the same space, which means the parts have to become smaller. So 8 to 6, 6 is going to be bigger parts because there's less of them to fit in. So Roxanne paints more of their poster red because the 4/6 is greater than 4/8. Compare, right? Less than, greater than, or equal to. Number 2, 3/4 is blank than 3/8. Same numerator, different denominators. I'm gonna look at that. I have to divide them into 8 equal parts or 4 equal parts. 4 equal parts is gonna give me less partitions, so each partition will be bigger in space. So 3/4 is greater than 3/8. 2/5 is blank to 2/3. Okay, again, dividing into 5 equal parts or 3 equal parts. What's gonna give me more space? 3 equal parts. So 2/5 is less than 2/3. Number 4, 4/6 and 4/4. What is greater? Or what symbol do I put in? Well, dividing into 6 equal parts or 4 equal parts. 4 equal parts is going to give me more space. So 4/6 is less than 4/4. Okay, we're cruising through. Last page. On a hike, Lily eats 2/3 of her granola bar. Pat eats 2/4 of his bar. Both bars are the same size. Who eats less? Explain your answer. So what is less? 2/3 or 2/4? If I look at the bar, I could divide this first one that Lily eats into thirds, and the other one that Pat eats into 4ths. Oops. Color in 2 of them, and see that Pat's covers less of the granola bar, so Pat eats less because 2/4 is less than 2/3. Compare the fractions. Write less than, greater than, or equal to. 3/4 compared to 3/6. Well, the denominators are different. Dividing into 4 equal parts or 6 equal parts. What's going to give me the most space? 3/4. So 3/4 is greater than 3/6. Number 7, 4/8 to 4/8. Easy peasy, those are the same. Number 8, 5/3 or 5/8. Do I want to divide into 3 equal parts or 8 equal parts? 3 equal parts is going to give me the bigger piece. You can think of it like that, like a piece of your favorite food or your favorite dessert. Am I gonna get more if I divide into thirds or into 8ths? I would get more if I divided to thirds. So you can think about it that way. Number 9, igneous rocks such as feldspar form when different types of melted rock deep inside earth cool and harden. Igneous rock sample A is 3/8 feldspar. Igneous rock sample B is 3/5 feldspar. So I'm gonna write that 3/8, 3/5. Both rocks weigh the same, so I can compare them. Which rock has a greater amount of feldspar? Explain. So again, the numerators are different. The numerators are the same, the denominators are different. So if I divide it into 8 equal parts or 5 equal parts, what's going to give me the biggest piece? That would be dividing into 5ths. So sample B has the most feldspar, excuse me. Okay. So that's it for the lesson. Let me know if you need anything. I hope that you're having fun with this. Once you get the hang of it, it's really quite fun to think about it, notice the patterns, and compare the fractions to each other. So I hope you're enjoying it. I hope you're starting to understand it. If you need anything, let me know. Love your guts. Bye.